Welcome everyone to the video series from Lighting Controls Academy, where we are going over all of our NEMA Academy videos to give you some video context of all of the curriculum that we've covered in NEMA Academy, but also to just give you an additional resource out there to learn about lighting controls. I'm the Education Manager for Lighting Controls Academy, Webster Marsh, and I'm here to give you a walkthrough of the lighting control system design. We're now in part 2, so if you haven't watched part 1, I highly recommend that you go back and watch part 1 first, because a lot of the content that we're covering in this is going to be of similar capacity, and we're going to rely upon some of the knowledge that we went over in part 1. Part 2 is about planning and coordination, and so what does that mean? That means we are going to first talk about how do you take those control intent narratives and sequences of operations and apply them to your design and continue to manage them throughout the process. We're also going to talk about modern architecture and topologies and how those affect modern lighting controls design. We're going to go over how to coordinate your lighting control system with the luminaires that are being selected for the project or vice versa. And finally, we're going to go over proper specification and documentation procedures, what you might want to keep in mind when you are finalizing your construction documents and getting prepared for construction administration. So first, how do we apply lighting controls intent? Using the control intent narrative and sequence of operations. These are living documents, which means that they are going to be updated throughout the life of the project and may even be updated during construction administration, but for the most part you want these documents to be completed by the time that you are issuing these documents. They will guide the designers, the manufacturers, the contractors, and stakeholders and give them some information about the system and how it's expected to perform and any additional information that might be required. They're also used to generate the submittals and bill of materials, which are documents used during construction administration, which we'll cover in part 3. They're also supplemented by other documents such as the drawings, specifications, and schedules that are created throughout the life of the project, and a lot of these documents will actually refer back to the sequence of operations, for example, because the sequence of operations will have much more detailed information that can't necessarily be shown in a device layout or in a schedule. So these work hand in hand with each other to be able to provide a complete documentation process. So the first thing to talk about when dealing with lighting controls is the controllers themselves. So what are controllers? Controllers are the devices that receive inputs, they process the logic, and they also issue commands. What does that mean? Well, it means that controllers might not actually be the sensors or the buttons on the walls. There might be a device further downstream, meaning past the device's signal point. So if I push a button downstream, it'll send a signal to some other device, oftentimes a controller, and that controller will receive that signal and, having been programmed, will know what to do in response to that. So if somebody walks into a space and a motion sensor picks up their movement, it will send a signal saying, hey, there's movement in this space. The sensor itself doesn't know what's happening or anything in the space other than the fact that it's meant to say, hey, there's movement, do what needs to be done, and the controller will then decide what needs to be done. And so the programming will often be stored in the controller, and the controller might even issue a command further downstream saying, hey, dimmers, dim your fixtures to full, or, we need to adjust the lighting. So they'll oftentimes be involved in that kind of procedure. So controllers are kind of the central point that you want to make sure everything's communicating back to. Additionally, there are different kinds of controllers out there. You might see with drivers that things are separated out. So you might have a power controller just for the purpose of controlling power to a device as opposed to power towards the lighting. I'm not going to spend a huge amount of time separating those two in this presentation, but just keep in mind that when we're talking about controllers, we do kind of cover a lot of different functionalities at the end of the day, but just so long as you're aware that the power controller and the lighting controller do function similarly in the capacity of storing that data. Selecting which controller can oftentimes affect the system capability, however, and so what you want to do is you want to keep in mind which capabilities you want to have in your system. And so that's why it's important to have your sequence of operations and your control intent narrative completed before you get into this process of selecting which controller to use and which brand you want to align with, because your sequence of operations should be the initial design and the manufacturer should align with that initial design. And so some systems don't have the same capabilities, such as with advanced capabilities like conditional logic. So making sure that your sequence of operations is thoroughly vetted, and then you can reach out to a sales rep or some other group that might be able to help you verify that the system that you're planning to select does align with your sequence of operations. That's very helpful to making sure that the system will be completed to your specifications. Additionally, mounting, communication, capacity, and aesthetics. So these are all important when thinking about the controllers, because some controllers are quite large and can take up panel-sized spaces on the wall and need to be in very specific spaces like electrical rooms, whereas some controllers are very small and can even be embedded inside of the luminaires. So that is an important piece of consideration for your controllers. But additionally, how are they communicating? Is it going to be wired or wireless? Capacity, meaning how many devices can it communicate with, and either two-way communication or one-way communication. And those really do kind of fall into a bigger conversation about how the system wants to function in its entirety and how information is exchanged throughout the system. But for the most part, these are always important considerations to keep in mind. And finally, the aesthetics. If the controller itself is mounted inside of something that you would see on a daily basis, like a switch, you might want to confirm with the stakeholders of the space, hey, is this an aesthetic that you like, or do you dislike this aesthetic, and should we go with something else? So let's go over some questions and how you identify the controller. The first one, as we discussed already, how does the controller communicate with the system? Is it going to be networked? Is it going to be standalone? Is it going to be wired? Is it going to be wireless? These are all important things to vet early on in the design process to make sure that your design is going to be adhered to and also signed off on, because let's say, for instance, an owner has hesitation about wireless and no conversation can alter their hesitation, you'll probably want to go with a wired system. So making sure that you select a controller that uses a wired communication signal is going to be an important part of the process. Additionally, identifying which controllers are visible to occupants. Are we dealing with wall switches or keypads? And are these aesthetically acceptable to the owner? Does the owner have specific wants or needs for their devices? And so as a result, making sure that you've clarified, okay, this keypad may not be a controller, but it's still an aesthetic choice and a part of the system. We always want to make sure that we've confirmed with them that this is acceptable, especially with sensors that can sometimes be mounted in the ceilings or in the walls. Just making sure that they're aware of what could be impacting the space's appearance. As mentioned, how are the controllers mounted? Are there any special considerations that need to be thought through? For instance, there's plenum rated, which means that the device can be mounted above ceiling tiles in the plenum space. And not all controller devices are plenum rated, and so as a result, you might need to find a new location to mount some of the devices that you were originally planning to put up in the plenum space. And then, are there any additional options or features available for these devices? For instance, if you're trying to do color changing DMX, which is a specific protocol oftentimes used in entertainment and color changing applications, the controller might not actually have the ability to control DMX, so confirming whether a controller has that capability, if you need that capability, will help make sure that the system is going to provide the controllability that you need. As mentioned before, do the controllers have a range or capacity? So on top of just capacity for devices, you might also need to verify how many buttons do you have. Can the buttons be reprogrammed? Can they be engraved, or how are they labeled properly? Or do you have a touch screen that operates as a controller? And how much reprogrammability do you have? How much flexibility do you have with that touch screen's graphical user interface, or GUI? And so all of these questions will help you really kind of refine to what kind of controller you're able to use or should be selecting for your project. All right, so now we're going to get into designing architectures and topologies with lighting control systems, which can be quite a deep topic, but we're going to try to distill it down to the bare essentials for this presentation. So first thing that we need to understand is, what is an architecture? An architecture just defines how devices and luminaires are organized, primarily how they are interconnected throughout a project or not interconnected throughout a project. So for instance, we tend to use these three major categories for architecture. The first being standalone, meaning that it doesn't communicate out. Oftentimes it's within a wall box device, meaning it's all the components are within one device, oftentimes replacing a switch or dimmer spot with this wall box device, and that way you just have everything right there, oftentimes in small spaces like janitor's closets or storage spaces where you don't have a lot of depth to them. So you'll see a vacancy sensor mounted with a switch, so that as soon as the space has been left unoccupied for enough time, it will switch the lighting off. So that's standalone. Room-based means that you're now controlling multiple zones within a room, but not communicating out from that room to anything else. Everything's contained within that room, and so you might have a sensor communicating to a controller, communicating to a keypad, or vice versa, and as a result, that whole room is just programmed together, going to operate together. Whereas networked is really when we get into the more advanced capabilities for a building-wide control system. So each space can communicate to each other or back to a central processor. And that way we have the ability to do data analytics on the project, or be able to control spaces from that computer that we don't necessarily have access to at the exact moment. Or even further, you could connect it to the internet, which would be an added feature for a networked lighting control system, and control your lighting from anywhere that you have internet connectivity. Now, just keep in mind that the term networked does not mean internet enabled. It just means that there's some networked communication, meaning that spaces or devices can communicate between each other regardless of where they are in the project. The architecture really does control how the system is going to communicate and any integration potential you have with that system. So as I explained with the different categories, your communication is going to be limited in a standalone system. Whereas if you have a completely networked system, you have a lot more capability for expansion and communication channels, such as creating integration between the system and other adjacent systems. You can still do room-based integration, however. So if you're just doing an an audio-video system that is communicating with the lighting control system, probably via a shared touchscreen, then that is still capable to be done through a room-based system. Oftentimes harder to do with standalone, but network systems oftentimes have a lot of integration capabilities on their own and additional devices that you can take advantage of. The sequence of operations is meant to help identify the architecture, primarily because it identifies the triggers and controllers within the system. How are you dimming? How are you switching? What is the expected performance of the system? That can all be determined within the sequence of operations, and you can even dictate whether you're planning to do a standalone room-based or networked system for those spaces, and that can help clarify exactly what is expected from that space. So standalone systems, so going a little bit more into depth here. So standalone systems operate independently within a space. You might have timer switches or occupancy sensors involved in this just to help give some capability of switching the lighting on and off based on some kind of trigger. You oftentimes have pretty limited flexibility and communication capabilities, if you even have communication capabilities. So standalone systems, again, are really great for back of house spaces, but not for front of house lobbies or something like that. But as a result, they are really good cost-effective option, and they don't have a huge amount of complexity to them, so they're very easy to program and start up. Room-based systems, on the other hand, you have devices communicating within a space. And you'll often hear the term distributed intelligence when it comes to room-based. Sometimes networked might even be called distributed intelligence, but what that means is you'll have multiple controllers all with their own logic, and so they'll all operate together in synchronicity, but they all have programming stored locally within each controller, as opposed to having a central control processor that has additional layers of knowledge and can take even further control of these devices. So distributed intelligence just means everybody's sharing the same level of responsibility, whereas a central intelligence would be a big processor somewhere in an electrical room or in a basement room. So you'll often see room-based systems in classrooms or conference rooms, especially if you're trying to do AV integration on a budget. So room-based systems are really great to achieve that. But as a result, they have limitations primarily in how you're going to be able to modify the system after the installation is completed. So just keeping in mind that they're less flexible than networked systems. And so building enterprise systems or network systems, this is where we are unifying all of the spaces together, and you might even have a room-based system per space, but then you're networking them all together to create a networked lighting control system. And so as a result, you're now taking a room-based system and expanding it to have networked capabilities. If you were to just leave it alone as a room-based system, it might still have elevated features above other room-based systems, but to give it additional layers, you would want to network those spaces together. And as a result, when you do network all of the spaces together, or a majority of the spaces on a project, you create this centralized programming and data accessibility. So oftentimes we'll see web graphics design where you have a web page that you can access all the data analytics for the project and see, okay, where is all the energy being consumed from, or who's using, which space is being used the most. All of that data can be collected and then provided through what's referred to as a dashboard. With networked lighting controls, you have the ability to integrate with building management systems, or BMS. What this means is that you can now kind of translate the data from the lighting control system to be sent to the building management system for coordination purposes, such as if you want to use motion sensors for both the lighting and the HVAC, you can then communicate with the building management system and be able to provide that sort of coordination capability without having to add additional devices like more motion sensors. So that capability is really a great additional benefit of networked systems. Finally, they have real scalability and flexibility. Some systems are very easy to add more devices to, relocate devices within, or add new phases to. So having a network system really does expand its capabilities within a lighting controls project. So topology just refers to the system's communication and how devices are connected on that system. It'll oftentimes be whether it's a wired system or a wireless system or even a hybrid system, meaning that it is a combination of the two. You might have some devices that are wired together and you might have other devices that are wirelessly communicating with each other. It oftentimes refers to how far you can go with its communication capabilities. So you might see distance limitations such as how long your wire runs can be, or it might even impact the reliability of the system, especially if you start to deviate from the recommended best practices for the topology of the system. And furthermore, it can even impact the cost because some systems might have very costly topologies, meaning that they have to be followed a specific way and have specific terminations for those wires where they're going to be ending. And so as a result, topology really does impact a lot of the system's design. But what's most important is that the topology is defined within the sequence of operations and how the triggers are going to interact with the system. In some cases, a trigger might need to permeate through the system and follow the topology in a specific way, in which case the sequence of operations should probably dictate that. Now, oftentimes you won't see that. In most modern lighting control systems for commercial projects, you don't necessarily need to know how the data is permeating within the system, but it's just something to keep in mind as you're designing a sequence of operations, how the system is going to interact topologically with itself. All right, so I'm going to go over the different types of topologies that we've mostly seen within the commercial lighting controls environment. There are plenty of other topologies out there, but for the most part, this is what we see within most lighting control systems for modern systems. So wired topologies either come in a daisy chain format, meaning that it goes from device to device and then ends. A bus format, meaning it follows a similar format as daisy chain, but it's a central bus of data that everything's connected to and routing back to the controller. Or star configuration, which can also be referred to as hub and spoke, meaning that you have some kind of device like a router or a switch that everything connects back to, and then if you want to add more connection points than your switch has, you'll add another switch and connect and sort of daisy chain those switches together to then extend the network's capabilities. But these are the primary ways that we've seen wired topologies work. Some systems, as I mentioned, are topology free, meaning they can use any of these different methods, although that doesn't necessarily mean you can just wire everything and walk away and forget about it. You might still need to give some form of logic to how you're wiring things together so that you don't create data collisions or bandwidth issues within the system. One of the benefits of using a wired system is its reliability for communication capabilities. Whether or not a wireless system is more reliable or less reliable than a wireless system is debatable, but for the most part, we've found that if you really are worried about communication for any number of reasons, wired is going to be the more reliable of the two choices, but that's not to say that wireless is a bad option. But regardless, if you're doing a wired topology, you do need to carefully plan out how you're wiring the system. A lot of wireless systems do give that flexibility where you don't necessarily have to pre-plan how you're running communication channels, but with wired, you really do need to plan out that path, and in some cases even provide support like rigid conduit to make sure that that communication channel is robust enough, because interference can still happen on a wire. Wireless topologies, on the other hand, come in point-to-point, meaning that you have a device communicating to another device, and that's it. Star topology, which is similar to our hub and spoke topology in our wired devices, but in this case, it is just replacing a wire coming out of the switches to being a wireless signal coming out of a router. And so as a result, we'll see similar kind of architecture with a star topology where we're daisy chaining devices together, but the devices that are chained together are just for communication purposes, and any devices like sensors or switch or keypads need to connect back to a router. And then finally, mesh networks. And mesh networks can sometimes be referred to as self-healing. That's not always going to be the case, though. And what that means is that if a device goes down, another device can take up its responsibility and continue communicating, because in a mesh network, you have the ability to enable any device to be both a sender of signal and a receiver of signal, which means that as you're system grows and you add more devices to the system, the data strength actually increases because all devices can act as a repeater of that signal. So once you hit a button on a keypad, that signal gets permeated throughout the entire system. Each device repeats that piece of information until it reaches where it's meant to reach, which might say, you know, I need controller number 37 to respond to this key button press, in which case only controller number 37 will respond, but everybody will be repeating that signal. It's kind of like taking a loudspeaker and shouting into it that as you're trying to receive one person's attention within a crowd, and everybody hearing your shout from the loudspeaker then starts shouting that person's name at the same time. And so while it might not be constantly repeating that information, it will eventually reach the right device if the network's robust enough. The benefit of a wireless system, as mentioned, is that we're reducing the wiring within the system. So it doesn't necessarily mean that the entire system is wireless. All it means is that some of the communication channels within the system are wireless. You oftentimes in a wireless system will still see some wiring between devices, oftentimes with controllers or with adjunct devices like bridges, but oftentimes you'll see most of the communication channels are done through wireless signal. Now that doesn't mean that a wireless system is powered wirelessly. Oftentimes we'll still see line voltage or low voltage powering the different devices via wires or some other way of connecting the devices together, but what it really is referring to is its wireless communication. As mentioned with mesh, it allows for a more robust connectivity, although there are some limitations to mesh, so it's not mesh is the best because of this ability to kind of repeat data. The data needs to be limited enough that it can be repeated like that, and so it might not be as strong of a data packet, meaning it doesn't have as much complexity or information as a wired solution or even a star wireless solution. So just keeping that in mind. But there is an argument to be made that when you're using a mesh system, it does have a redundancy within it that allows it to become a more robust communication point. But as with anything wirelessly, we want to make sure that radio frequencies are planned for. So if you have what's referred to as a saturated airwave space, you want to make sure that you're able to live within that saturated airwave space, because a lot of wireless signals occupy our airwaves nowadays. We have a lot of Wi-Fi, for instance, within a building that is for the purpose of connecting all of the computers together. And if we're using the same radio frequency channel as that Wi-Fi, we can have what's referred to as data collisions, which then create issues with communication or even completely halt communication on a wireless. So we would just want to make sure that we're communicating with all of the appropriate groups that we're using a wireless signal, and make sure that we're not going to create any issues or find any collisions within the systems. All right, so I've mentioned this word before, but let's actually go into it. So protocols. Protocols are ways of defining the communication rules. If we didn't have these definitions, we wouldn't have the ability to communicate between the different systems. And so having protocols really does allow us to make sure that communication is done appropriately. There are basically two types or two major categories of protocols. The first one being proprietary and the other one being open. Proprietary means that it is not available to everyone, and as a result, there's going to be very specific brands that have access to that protocol. And in North America right now, a lot of our systems operate on a proprietary protocol. And so as a result, you might be able to have brand X's lighting controls devices on your project, but you can't just grab brand Y's devices and expect them to communicate with brand X's system because they're using a proprietary protocol. Now, proprietary protocols might resemble open protocols being based on an open standard and available to anybody who wants to use them. Examples being Dolly, DMX, 0 to 10 volt. Those are all open standards for the accessibility of anyone who wants to take advantage of those protocols. It's important to note that with protocols, there's also what's referred to as front-end and back-end protocols, which really just refers to where in the stream on a system is that protocol being utilized. Many lighting control systems utilize different protocols within the system and then communicating out to the luminaire. So you might have a front-end protocol, which might be a proprietary protocol going from the keypad to the controller, and then the controller might use an open protocol out to the luminaire, which would be the back-end protocol. So you might have DMX out to a luminaire connected to a controller, which would be a back-end open protocol communicating with a proprietary system. It's important to confirm the compatibility and function of a protocol, because there are a lot of protocols out there that may seem similar or have the same name as another protocol, but they actually don't work together. They don't communicate together. So Bluetooth is an example of a protocol out there that deserves a little bit of care and attention when specifying, because a Bluetooth system might employ a Bluetooth NLC, which is an open standard for networked lighting controls. But if you're not using Bluetooth NLC, you're just using the Bluetooth on your smartphone, for instance, that might be a completely different Bluetooth communications standard. And so as a result, you just want to make sure that your devices are going to be able to communicate together, especially if you're going to use different manufacturers' products. So if you have brand X's Bluetooth NLC device and you want to use brand Y's Bluetooth NLC device, it's always good to just confirm that they're able to communicate together. So let's get into luminaire coordination, where we want to make sure that the lighting control system is capable of controlling our luminaires and that our luminaires are compatible with our lighting control system. So when we are creating our lighting controls design and we are creating our lighting design, if we happen to be the same person, we want to make sure that the two of them are coordinated appropriately. It's not enough to just say in a luminaire schedule, this is a 0 to 10 volt fixture, and then expect somebody else to be able to make sure that the system can control 0 to 10 volt. The controls designer really should be communicating with whoever assembles that schedule what their protocols that they're using are going to be. And what that really boils down to is which drivers are being used. Sometimes figuring out which driver that's being used for the fixture can be a challenging thing to do, because oftentimes manufacturers don't necessarily disclose that or publish that information. But the other thing is that as a controls designer, the driver really is the handshake point between the luminaire and the lighting control system. So verifying which driver that's being used and what control protocol is being implemented really does ensure that that lighting control system and the fixture are going to be compatible and you're going to get the results you want. So making sure that you've coordinated that early on, even during SD phase if possible, can really help avoid costly rework later on down in the project timeline. And furthermore, when you're dealing with integration, it really is essential. We oftentimes see integration with lighting control systems at this level with DMX, so making sure that you've identified that the fixture is communicating DMX, that the controller is communicating DMX, which version of DMX is being implemented. All of that really needs to be vetted and verified, because if it's not, then you can have some really unfortunate results that result in costly reworks or reinstallations. So when going through the luminaire selection, it's important to really state clearly within the luminaire schedule any control relevant data. And what I mean by that is primarily what driver type and what protocol are you using with that luminaire. There might be additional information, such as if you're using a DMX 512 fixture, it might have what's referred to as different resolutions, meaning that you might have a 4-foot fixture, but every single foot within that 4-foot fixture is being controlled independently. And so that resolution really does impact the control system's needs and capabilities, or at least what you need to be providing to control that fixture. So including that information in the luminaire schedule really does prevent any issues later on, because if it's uncertain what resolution is being provided for that fixture, the wrong resolution might be selected, and the system might not be capable of controlling that many sections, that many segments within the luminaires. If you have dozens of these fixtures and they all have 1-foot resolution and you're only planning on 4-foot resolution. So that's a really important criteria. So just thinking through what is control relevant for this fixture. And so what this will do is it will support the contractor's coordination capabilities. They might look at the schedule and say, okay, we're using these specific drivers, so I need to coordinate mounting location for that driver, if it's going to be remote, how it's connected back to the system, if I need to route additional wires to the fixture. All of this is really helpful for them to understand. And additionally, as mentioned before, it will help prevent those compatibility issues if it's already been vetted that yes, this is using DMX 512, it has this resolution, the lighting control system needs to have that capability of controlling this fixture that is communicating DMX 512 and has this kind of resolution. So driver coordination is very similar to luminaire coordination in the sense that it is still part of that luminaire coordination. But the drivers are the part of the luminaire that are receiving those control signals and interpreting them to then create the lighting effect that is desired. Some drivers will provide auxiliary power for additional devices, especially in systems that employ a triple LC or luminaire level lighting control system, meaning that each luminaire has its own control device embedded within it so that you have that more granular control capability over the system and the lighting. But whether you need that auxiliary power or not is important to confirm and vet when you're specifying your luminaires, because if you're planning on doing triple LC or something similar, you will need that auxiliary power to be provided to the devices. Additionally, mounting needs to be considered, as mentioned with remote drivers. If your luminaire has a remote driver, it needs to be mounted somewhere, and identifying where that is going to be mounted is really helpful to the build team so that they know where that driver is going to be located, how far away from the fixture it needs to be, and finally, how drivers are interconnected. Meaning topologically, how are they wired together if it's a wired system, or how are they communicating back to the system if it's a wireless system. If you have a electrical box filled with drivers, but they're all communicating wirelessly, are they close enough to the system to be able to communicate back to that system? Or do you need to add a bridge or a repeater in between where that driver box is going to be and where the rest of the lighting control system is going to be? Those are important things to consider when you're dealing with these drivers. And then additionally, advanced functionality. So what this oftentimes refers to is tunable white or color effects. Does this fixture have that capability? A lot of luminaire schedules will identify what static white color it is, but it's important to clarify, okay, is this fixture going to have RGB, RGBW, RGBWW? There's a lot of different color changing options out there, or tunable white options out there. So it's important to identify which of those the luminaire is going to be having, because the lighting control system needs to be able to control that. And not every system has the ability to control every kind of tunable white out there or every kind of color changing effect out there. So identifying exactly which kind of effect is going to be provided by this fixture will help coordinate that lighting control system. It's best to define in the sequence of operations what the effect is going to be, And then in the luminaire schedule, it's important to identify what colors are going to be independently controlled. So some, for instance, fixtures that are warm dim don't have independent control for their colors. It is just about how bright the fixture is. So at full output, it's at its coolest, and at low output, it's at its warmest. And so that can just be stated within the luminaire schedule and won't impact the lighting control system. But if it's tunable white, and that means that you have that independent control, full output doesn't necessarily mean any color, or lowest output, that means that we need to have that controllability programmed within the lighting control system, which means the sequence of operations should cover that information. Additionally, the advanced functionality that is outlined above, or even further, such as pixelating the lighting, that will impact what protocol is being used, what controller is being selected for the system. So identifying advanced functionality early on in the design process really helps make sure that that system is going to be complete and is going to be connected to the right luminaires and controlling it with the right system. And so that way, if you follow all of this, you're going to get the correct system selected for the control of your light fixtures for the advanced functionality. Finally, OEM devices. So if we are going to be adding devices to a fixture, this is where this term comes from. So original equipment manufacturer is what OEM stands for, and that oftentimes means that either you're dealing with a device that is sourced from a third party, or you're speaking exclusively about the sourced material for something. So for instance, if I have a triple LC application, I might have that motion sensor that's going to be embedded in the luminaire to be from the same manufacturer, or it might be sourced from another manufacturer but still installed in that fixture at the factory of the first manufacturer. So let's say brand X's luminaire has brand Y's sensor in it. Brand Y will ship their sensor to brand X's factory, and brand X will install brand Y's sensor in brand X's fixture at the factory and ship it all as one unit. So that's an example of how OEM can work. This oftentimes we'll see with sensors or drivers. Most drivers are not fabricated in-house by the manufacturer that makes the fixture, and so as a result they will OEM drivers, which is another reason why it might be hard to pin down exactly which driver is being used in which fixture, because this can change sometimes. But it's important to identify exactly who's responsible for the installation, because sometimes OEM might mean that the device is now being installed in the field rather than in the factory, which can impact the cost of installation for the project. And if the contractor did not plan to install a dozen sensors in a dozen fixtures in the field, that might be an additional cost to the project that wasn't planned for. But at the end of the day, if you can get through all of that, you're going to make sure that the system is compatible, because if you're using OEM devices, it's always good to just chase down who's doing what, when, and how. All right, finally, the lighting control specification process. So this process can be quite comprehensive and quite challenging, but we're going to take you through it as best as we can. All right, so the first thing that you want to do is select your devices. Now that you have a clear idea of what fixtures are being used on your project and what your sequence of operations is expecting, now you can really get into device selection. A lot of people will design this in the opposite direction, where they'll start with their devices and then complete their sequence of operations in the luminaire schedule. But the reason we're suggesting you follow this process is because this is the way to really get the functionality that you need out of your system, instead of locking into a manufacturer's device array and then being stuck to that manufacturer's capabilities. Each manufacturer has a lot of different variety within their system, and so it's always good to make sure that your sequence of operations aligns with what that manufacturer can provide. Otherwise, you might need to select a different manufacturer, and so if you have started by selecting all of your devices, you're going to have to redo all of that work again. So that's why we're suggesting that you Save device selection towards the end of the design process rather than at the beginning of the design process. So device selection really occurs after the design has been finalized, after you've had all of these coordination meetings and ensured that you understand exactly what is expected of your lighting control system. Now that doesn't necessarily mean that it needs to be step by step, but so you might have an idea of what system you're going to go with. But it's always good to just confirm, okay, this is the functionality that I want, and then identify the devices. Additionally, you'll want to make sure that that architecture and protocols are aligned with your sequence of operations and all of these design expectations that you've had throughout the coordination meetings. Once you get to device selection, however, you are going to drill down to a specific manufacturer, especially in North America. Outside of North America, it will oftentimes be a little bit different, dealing more with open standard protocols. In North America, you're more often going to be dealing with proprietary protocols to communicate within the system. And so as a result, you're going to oftentimes pick a manufacturer and work with that manufacturer's options of devices. When you're selecting the devices, it's always important to keep in mind the stakeholder or the owner's preferences for the system, because as a result, you might be misaligned. And so as you're picking devices, especially devices that are going to be highly visible, keypads, touchscreens, it's always a good idea to just confirm with the stakeholders, hey, this is what I'm planning to use. Does this look good to you? Layout considerations. This is where we're going to determine where we're mounting everything. This is a really great opportunity to make sure that your mounting locations align with expectations. So you might want to do a device layout and show that you have a keypad in a specific location. It's also a good way to coordinate whether or not that keypad might get hidden behind a door, because if the keypad's on the door swing side of the door, the door when it's opened might completely block visibility to that keypad, which is oftentimes a bad choice. And so it's always good to have your keypad constantly visible when the door is open or closed. That way you really do get a chance to coordinate with the architecture of the project. So there's other sorts of considerations, such as sensor mounting locations. If it's a tiled ceiling, ceiling mounted sensors might be a good option. Whereas if it's an exposed ceiling and there's a very high location where a ceiling sensor might be mounted, it might be better to look at a wall-mounted sensor instead. And so when you're really looking at that architecture and the layout, you want to think through distance limitations, such as if you're using wireless, how far away can devices be from each other before your signal starts to degrade, especially in a mesh-based system. Mesh-based systems are great for large areas with lots of devices within them. They're not so great for long, thin areas that just have a single chain of devices. So those are things to just consider as you're looking at the device layout. And then finally, you can avoid construction conflicts. So if you're planning on putting an occupancy sensor in a tiled ceiling, the tile that you select might actually have a HVAC diffuser or return on it, which will actually cause false activations of that sensor if it's mounted right on it or adjacent to it. And so making sure that you've identified the conflicts that might come into play really helps ensure that that layout is going to be a complete and helpful version for the construction team to follow. So wall stations, or keypads, touchscreens, etc., this is what we refer to instead of switches. Switch really does mean a device that just turns things on and off, and we're trying to get away from that term, although even within this presentation I've used that term a lot to refer to a wall station. But wall stations are those devices that give you that accessibility, that touch point for the lighting control system. So we oftentimes see these either as standalone wall box devices, programmable, meaning they could be keypads, or we might even see scene controllers, meaning that they have additional features like the ability to raise and lower the scene that is active, or additional scenes, or even zones specifically. So all of these have a variety of options, so identifying what flexibility and complexity that's expected by your occupants is really important. They might be able to control a single zone or multiple zones. As mentioned, they might even have the ability to adjust each zone independently. But as with anything that an end user might need to interact with, there's going to be training required so that the end users have that knowledge and awareness of how to use this device. Oftentimes, if the space is going to be used by a variety of different end users that you can't necessarily track down and train, you want to keep things simple for your wall stations. If it's a space that's going to be heavily used by one specific group, or even an individual who's responsible for that space, like a facilities manager or an operator, then you might look at more complex, but you probably would want to have a conversation with that person during the SD phase to identify exactly what they need to be able to achieve what they're trying to do, such as if they're controlling the lighting for presentations, or they're controlling lighting for a stage that has theatrical type experiences expected on it. All of that should probably be discussed and coordinated during the creation of the control intent narrative, which would then eventually translate to where you're putting your wall stations and which wall stations you're using. Sensors. I've mentioned sensors a lot, and hopefully you have some knowledge of them, but ultimately we've got two types of sensors out there: motion sensors, which enable shutoff, and daylight sensors that support daylighting control. And so motion sensors, or occupant sensors, have the ability to either turn lighting on automatically when somebody enters the space, or not turn the lighting on and wait until somebody manually activates the space, which is what used to be referred to as vacancy sensors, although we don't necessarily delineate that as much anymore. But either way, they will always shut off the lighting after a certain timeout condition. Daylight sensors, on the other hand, are going to either detect the contribution of outdoor lighting into a space, or they're going to monitor the lighting inside of a space and adjust based on the contribution of the outdoor lighting alongside the electric lighting within the space. We also have the ability to sense the loss of power under a normal condition and ensure that the emergency lighting is then turned on under an emergency condition. And we'll get a little bit more into this, but the point of this is to just say that the sensor has the ability to sense the presence or absence of power on a normal circuit. So another device which is found in lighting control systems is time clocks. And what this does is it controls the lighting by time. It doesn't necessarily have to be time of day. It could just be a basic timer that once it ticks down to 0, turns the lighting off, and you have to reset it manually. Or it could be an astronomic time clock, referring to the ability to dial into an exact geographic location so that you have that sunrise, sunset perfectly aligned for your exterior lighting to turn on at a specific point when the sunset happens or sunrise happens and the lights shut off. That's a really great feature within time clocks. So there's a lot of variety how you can really control the lighting via time. You oftentimes see nowadays time clocks integrated within other controllers, such as touch screens will have astronomic time clocks embedded in them, or panels might even have time clocks in them. So it doesn't necessarily have to be a separate device like it used to be. And it might even be able to support additional kinds of scheduling logic, such as if there's holidays that the building isn't going to be open on, doesn't necessarily turn the lighting on during those holidays. Or even further, it might be able to help control the color changing lighting, so that if you have a specific holiday you want to match colors with, you can dial into that on your scheduling as well. So additionally, you might need to identify remote devices similar to OEM devices. So they might be factory or field installed devices that are remote to the lighting control system. Similarly with triple LC type devices mounted into the luminaires. If you are going to be doing field installed devices, you will oftentimes need to consider the fact that there's going to be additional labor on top of the cost of the device itself. But these field devices might be a power supply for a touchscreen, so you might need to have something located nearby the touchscreen that converts AC line voltage to DC low voltage, or you might just need additional devices to support another device's functionality. So getting an idea of what the remote devices are going to be, how they're going to be installed, will help clarify any additional requirements for that device and its functionality. If you're going to have what's referred to as assembly, where it's a conglomeration of remote devices, you really should define what that assembly is going to be. So for example, if you have a electrical panel that has multiple devices installed inside of it, like a power over Ethernet switch that is providing power to a touchscreen, but it's also using a low voltage power supply within that panel, all of those parameters should be defined in the diagrams that you're going to be providing to the construction team so that they understand what is expected of that panel, how it's going to be installed and programmed. And by doing so, if you really identify all of these remote devices, you're going to avoid scope gaps, because oftentimes remote devices are where you will find scope gaps happening within a project, because either you didn't realize that the touchscreen needed a remote power supply, or you didn't understand that there's additional components that need to be put inside of the the electrical panel. And so really vetting that out, wringing it out, making sure that you have every device for the lighting control system to be complete really helps avoid those scope gaps. Integration is a really important thing to identify as early as possible. What it does is it allows different systems to work together, and you might even find integration within the same system for the purposes of communicating between two unrelated devices, such as, again, DMX512 is a perfect example here. You're actually going to be integrating the DMX512 fixture into the lighting control system, because odds are that lighting control system is not natively speaking DMX512, but rather using a device that then integrates with DMX512. And so additional forms of integration, as I've mentioned through this presentation, are HVAC and AV. So you might have very simplistic integration where you're just using contact closures to power or relays to power on and off devices, or sending very basic signals between the systems. But you might also have much more comprehensive integration, allowing for dual communication between the two systems and allowing a lot more data to be passed along, so that you can really provide a complete network of data rather than just a local device. What you gain by integrating systems is really an improved efficiency and a more streamlined user experience, because by having reduced number of devices in the project really does make it a much more accessible solution. And so you don't have to track down all of the different devices. If you have redundancy, like a motion sensor in every space alongside an HVAC motion sensor, you can reduce that down to one motion sensor. And so if there's an issue with the motion sensing in a space, you can just locate that one device rather than having to pick which of the two devices need to be addressed. And as a result, your troubleshooting efficiency is going to go up. Also, if you're combining your wall stations into one, where you just have one touchscreen that has both AV and lighting control, it makes it a lot easier to find where that controllability is. And so if you have two touchscreens or a keypad and a touchscreen, it can sometimes be rather confusing to the end users to have to figure out which is controlling which. But if you really want integration to be successful, you want to define it in the sequence of operations and clarify not only that there's integration, but what is that integration? What protocol is it using? What are the expectations of that integration? What happens when this trigger activates? Which systems are responding? How is it responding? There's a lot of information that needs to be outlined within integration. Emergency lighting control. So I mentioned this before, but let's get a little bit more into the weeds on this. It's basically a life safety code requirement. And so emergency lighting control allows for people to evacuate a building under an emergency power loss, or in some jurisdictions during a fire alarm activation. And what it does is it overrides the emergency lighting so that you get it to an emergency level. Now, it might use either emergency circuits being fed by a generator, or it might be an inverter or a battery backup that is powering the light fixture. But what we need to do is override those lighting controls so that when we are in an emergency state, the normal controls are not controlling the light fixtures. The light fixtures are just being forced to their emergency state. It used to be full output. It is no longer just full output. We can have certain intensity values now, but what you need to do is make sure that your lighting is going to its emergency state under emergency conditions, either with a loss of power sensing circuit or with a fire alarm activation in some cases. When we are finalizing the emergency lighting controls design, however, we do need to make sure that this is coordinated with engineers so that they can confirm that, yes, this is going to meet the requirements. Because if, for instance, you're a lighting controls designer and you're not an engineer, regardless of emergency lighting control, you do need somebody to stamp your drawings in a commercial environment. So having an engineer involved is critical to the success of the project. But if you're doing emergency lighting control design, especially, you will need to coordinate with the engineers to make sure that it meets their needs for emergency egress lighting. All right, we're almost done here. So we're preparing for construction. How do we do that now that we kind of have all of these ideas of lighting controls and design in mind? First, we want to make sure that we have a final coordination meeting. Regardless of where we're at, whether we anticipate that there's going to be revisions to the drawings or not, we want to make sure that we're coordinating everything and identifying that what we're specifying is actually going to be implemented and is expected to be implemented. So reviewing the control intent narrative, sequence of operations, and drawings and diagrams that we've provided really helps clarify with the team what is expected of the lighting control system and make sure that they agree that that is what should be happening with the lighting control system. It additionally helps clarify any scope alignments. You might even want to create something called a scope matrix if it's going to be a complex layer of scoping, such as if you have building management integration. So making sure it's clarified not just who's responsible design team-wise for something, but also construction team-wise. You know, are the lighting controls devices going to be provided by the electrical contractor, or are they going to be provided by the mechanical contractor? That's something that can happen in building management system design. But if we do all of that, we really are going to support a smooth construction process and make our jobs in construction administration a lot easier at the end of the day. So what did we cover in this section? Mostly how we plan and coordinate lighting controls. There's a whole lot of other stuff we could have covered in part 2, but in reality, what we want to do in the design process is make sure that the system is coordinated and designed appropriately, and we've planned accordingly so that the next part is a lot smoother to get through. So if we properly coordinate, specify, design, we will have a much more smooth bidding, pricing, installation, and commissioning process. Whereas part 3, we are going to be covering the installation and the post-occupancy within a project. Thank you for joining us, and hopefully we'll see you in the next one. Before you go, a quick word about who we are. For over 25 years, the Lighting Controls Academy has served as the voice of the lighting controls industry. As a coalition of the National Electrical Manufacturers Association, or NEMA, we were created to help educate the public on lighting controls technology and real-world applications. Our hallmark program is our online education, including this video series, along with written courses through NEMA Academy. If you want to keep learning about lighting controls, head to lightingcontrolsacademy.org. You'll find articles, industry news, new products, award-winning projects featuring controls, and plenty of other helpful resources. Thanks so much for watching, and hopefully we'll see you in the next one.